Well, welcome everyone to our session on digital engineering for defence and intelligence mission success. My name is Jonathon Beesley, and with me today is my colleague Lloyd Hewitt. But before we get started, let us introduce ourselves. So as I said, my name is Jonathon Beesley. I have short brown hair. I'm wearing reading glasses and a checkered shirt under a blue V-neck jacket. I'm a white Caucasian male, and in my background there is an office space with grey brick walls, a small office desk, and a green palm tree near a large window. It is my absolute pleasure to be here with you today. I've been at Microsoft now for just over 18 months as a vertical business lead within our worldwide public sector defence and intelligence leadership team. But prior to coming to this role at Microsoft, I spent just over 30 years in the Australian Army in command, leadership and management roles, predominantly within the special operations community. My last role in defence was to lead a task force focused on working with global partner nations to identify and mitigate against emerging and future threats and technologies. What a great role it was to roll into what I do now. But now let me hand over to Lloyd to introduce himself.
Thanks, Jono. I'm Lloyd Hewitt, and like Jono, I'm also a vertical business lead in the worldwide defence and intelligence team. I'm a white middle-aged man with thinning hair, trimmed beard, and wearing glasses. I'm dressed in a light blue shirt. Before joining Microsoft in December 2020, I served as a naval logistics officer. In my naval career, I was often faced with issues arising from disparate systems and a lack of through-life data when supporting equipment through its life cycle. Digital engineering approaches have the potential to solve some of these issues, and I'm hopeful that defence forces and their partners will accelerate their transformation efforts, incorporating digital engineering into that journey. Over to you, Jono, to get us started.
Awesome, thanks Lloyd. So to ensure competitive advantage in a rapidly evolving security environment, allied militaries must adopt a systems and portfolio-based framework. This framework should align strategic decision-making on future capabilities to the mission areas required for integrated deterrence. And while kinetic effects remain important, technical superiority has emerged as a key lever in maintaining this advantage, especially when it comes to piloting new acquisition pathways, modernising concepts of operations, and driving transformation goals. As defence and intelligence organisations embark on their digital transformation journeys, they are increasingly looking to technology to assist in the design, development, deployment, and sustainment of military assets, as well as increased agility and speed. This requires a shift for both defence and their industry partners from legacy methodologies to a digital engineering approach. Now, given the nature of today's audience, you all, we're pretty confident you have some sense of what digital engineering is, but we'd actually like to take you on a journey of discovery from a Microsoft defence and intelligence perspective on how the future of digital engineering is modernising the capability lifecycle, with some fantastic customer and partner examples to highlight what is already achievable to succeed in defence and intelligence mission. But to get started and to bring us all onto the same page, let's talk about what digital engineering is. So by definition, digital engineering is an integrated digital approach using authoritative sources of systems, data, and models as a continuum throughout the development of a life of a system, from concept through disposal. It's an offshoot of model-based systems engineering. But it's a bit of a mouthful, so perhaps more simply put, digital engineering is the use of digital models and data, real world or simulated, to improve and support the full capability lifecycle. Why is it important? Well, it modernises traditional systems engineering practices to build systems better. It takes advantage of commoditised tech, modelling, simulation, modern development approaches, and AI to enable, ultimately, innovation at the speed of relevance. And that is the why, innovation at speed. So, and that is critical to success in the mission for defence and intel. So now let's take a quick look at a recent example where Microsoft and BAE Systems have partnered up to explore and exploit opportunities in digital engineering.
The Naval Ships Combat Systems, we design, develop and deliver combat systems equipment and services right across the life cycle and pretty much right across the technology stack in the maritime domain. I'm really excited about my business working with Microsoft because we're at a really pivotal stage of technology for combat systems, and cloud computing is a real big enabler for that.
What we're trying to help Defence do with Mission Cloud is really think about how they can use commercial technologies to help them solve information and analytical problems with data in and around the battle space.
What we're trying to develop here is really the next generation of mission system products for the Royal Navy and other navies beyond, where the combat management system is a collection of applications providing different capabilities depending on the particular mission that the ship needs to execute.
Alongside BAE, we've been collaborating on putting together a secure development environment in the cloud, which will enable them to develop software faster and deliver to their customers quicker.
The current project delivers a new way of thinking about mission systems applications and how we might use artificial intelligence to improve our situational awareness on a platform.
Tactical picture is the view of the battlefield given to the naval officers. With the Microsoft team, we've been looking at improving the tactical picture through Azure's cloud-based services such as machine learning, cloud computing and microservices.
We can bring deep expertise in areas such as DevSecOps, digital twins, augmented reality, ML. The sheer scale and elasticity of the cloud is something that we have a great deal of expertise in.
Building out infrastructure and the compute resources and the scalability provided at the Azure platform is just staggering for us. It's a step change in place using Azure platform in our development process. There are aspects of the pipeline that allow us to do things in 5 minutes that would normally take 5 to 10 days in terms of building out infrastructure to deploy on. The Azure platform will help the Royal Navy in terms of being able to provide the pace and agility they need to respond to the operational demands.
The moment we started talking about this with Microsoft, we went from 0 to a team ramped up and working in a timeline around 4 weeks.
Working with the BAE team has been great. They have a great deal of experience on their industry and we bring a lot of expertise on the cloud. Both teams working together is just a great experience.
We want to work with partners across both the defence enterprise, commercial enterprise, and we want to provide our customers with the very best technology we possibly can.
I think the opportunity for Microsoft and BAE Systems together is to produce new capability, and for that new capability to really accelerate what the Royal Navy can achieve on ship and in the battle space.
I also feel like it's very interesting just to take two great companies and take little bits of them and smash them together and see what drops out of the other end.
The collaboration from the teams has been something that excites me. I'm really pleased to see how two very different companies with very different cultures, very different markets have been able to work together to solve a problem for a joint customer. I think, that's a really powerful thing.
Well, now let's take a deeper dive into digital engineering and the capability lifecycle with Lloyd. Over to you, mate.
Thanks, Jono. It's probably worth starting with a view of the defence capability lifecycle, as it is today, compared to where we want to take it. A future where our key defence and intelligence customers can develop and deploy new mission capability at the speed of relevance. So let's take a look at where we see those changes occurring. We currently see a landscape typified by information and capabilities being siloed, whereas we need to break down these boundaries and provide a common platform on which all stakeholders can collaborate effectively. Despite the Agile Manifesto being introduced over 20 years ago, we continue to see the waterfall approach dominate, when what we require is the use of Agile methodologies and processes to speed the time to value. Risk aversion continues to drive the capability development culture. Instead, we need healthier risk postures and acceptance that some failure along the way is necessary to optimize the final product. Often, non-functional aspects, such as security, are dealt with separately and introduced at the end of the process, rather than being baked in from the very start. And finally, we see an abundance of proprietary in-house systems rather than open source approaches, incorporating common standards and architectures that aid integration and allow the commoditization of technology. You'll note that although we are talking about the mission capability lifecycle, which can be a complex and tech-intensive topic, many of these elements are driven more by culture and policy than by the technology itself. For instance, most defence acquisition processes have been around for decades. They were well suited to building large, complex platforms and systems with well-defined requirements and waterfall development. But as defence and intelligence organisations are now more frequently addressing mission capabilities that are increasingly software-centric and are looking to buy those in accelerated timescales, then our legacy defence procurement methods are no longer fit for purpose. But we recognise that this is a paradigm shift, and it requires not just technology, but also policy and culture change. It is, however, something that we must continue to chip away at. And I look to all those engaging our defence and intelligence customers and the defence industrial base partners to have this conversation and bring the notion of change to the forefront. Accordingly, as I talk through these slides, I'd ask you to think about your customer and their current processes, and whether their processes, policies, and the capability frameworks currently provide the speed and agility that modern military organisations need. Let's dive now into some engineering perspectives and what this means for defence. Here is a look at what has been in place for the past 3 decades. Anyone who has worked in engineering disciplines across the defence industrial base, or DIB as it's often referred to, lives by this system engineering V. It has been the guiding principle of engineering for the last 30 years. So what are the challenges that we see are associated with this approach? First, this life cycle is traditionally executed sequentially, from the top of the left-hand V through to the top right-hand. In addition, all of the requirements are defined up front. Great for the risk-averse who like to take years polishing their outcomes until perfect on paper. But what this doesn't consider is that technology is advancing at a rapid pace. Just recently, I toured a French submarine that was commissioned in the 1960s, and I couldn't help noticing that it was very familiar to the submarine I served on 30 years later, despite the fact that technology had advanced significantly. Many of these capabilities in my submarine were still legacy because of the long development pipeline. Within this V approach, it is also very difficult to introduce new scope or unexpected changes midstream. Look back on how missions have changed over the last decade, and now consider how the most critical of equipment has failed to keep pace. One of the most concerning weaknesses, however, is the limited opportunity for feedback. This type of process mostly excludes the voice of the customer, which is mostly mute after the initial requirements analysis. Furthermore, testing is reserved for the final steps in the process, which increases greatly the risk of integration issues and usually results in higher cost and time to implement change. Finally, a key consideration is that critical elements like safety, security, and sustainability, remember my points about integrated logistics support, are afterthoughts. They're not baked into the system lifecycle, nor integral to any processes therein. It's time to overhaul this mission capability lifecycle. It made sense for legacy platforms, but it doesn't work so well for modern, rapid, agile software procurement. So here is what we believe the future looks like from an engineering perspective. And here I must pay tribute to Kate Middleton, our CTO, who has provided us with this view. What you can see is a combination of, on the left, the diamond diagram, which is a model-based engineering methodology, and on the right, a typical DevSecOps methodology. We believe this is a powerful combination that has the potential to unlock innovation at speed for defence forces. So what are the benefits of this approach? First, this provides significantly greater agility in requirements development and deployment of new mission capability because it's iterative. We don't need to define 100% of the requirements up front, and nor should we. This approach also helps us prioritize feedback loops. The voice of the customer is baked in throughout. That allows you to prioritize the highest value capabilities, and there's no need to wait a decade to deliver one monolithic final product, which, by the way, has now likely become obsolete, no longer meets the requirements. Instead, we can deploy incremental capability. This mirrors the best practice from the commercial tech world, and it's a great way to get frequent customer feedback because you are putting new capability in the customer's hands more regularly. This approach is rooted in the digital thread and a data-driven posture. Data is the fuel that drives a successful digital engineering approach. The use of digital twin allows modeling of real-world and simulated inputs, which allows integration of people, process, tools and data, and enables testing of a near infinite number of scenarios before ever going to production, or even a physical prototype. This is what the future defence mission capability lifecycle looks like, and customers are already starting to adopt it. This approach is increasingly popular in the aerospace and defence industry because it essentially does two things. It modernises traditional systems engineering practices to build systems better, and it takes advantage of commoditised technology, modelling and simulation, modern development approaches, and AI to enable innovation at speed. At the heart of the modern digital engineering approach, we can identify 5 key tenets. Model-based engineering, as we discussed on the previous slide in the diamond model. Second is the application of an authoritative source of truth. We can consider this as the models and data sets used by all of the engineering disciplines across the entire capability or system being developed. Next is the use of agile software methods and automation at scale, which introduces iteration and user feedback into the capability lifecycle, as well as automating important but sometimes laborious tasks like testing and metrics collection. Fourth is the introduction of technology innovations to improve engineering practices. Examples of DevSecOps, CI/CD pipelines, digital twin, container orchestration, etc. And finally, culture. This is critical and it's foundational to the entire digital engineering movement. As I mentioned up front, we must get the culture right for any of this to work. So far, I have introduced digital engineering at a conceptual level, but I'm sure that many of you will be asking, how do we bring digital engineering to life for our customers? Well, first think about the MSEM cycle and start with engagement. In that listen and consult phase, we must look for every opportunity to work side by side with our customers and partners on co-engineering efforts, where we help the customer develop IP and where we introduce digital engineering fundamentals into the process. Jono showed a great example of how we have done this in the BAE video, but this is not just for the DIB. We can apply this equally to end customers who are employed in capability development areas of their militaries. We at Microsoft also offer a host of capabilities that support digital engineering, some of which are highlighted on this slide. I won't go through all of these in detail, but I do recommend that if you're interested in a deeper look, please go to the Manufacturing Industry Hub and to their sessions at Ignite. They will delve into much greater detail than me and provide you with the technical granularity as required. But I would like to call out the ISV, or independent software vendor, listed at the bottom of each capability list. This is where we can really start to add value to our customers. When we bring non-traditional partners, including startups, into the defence technical stack, this helps bring innovation to the front line. And of course, you're aware that a key focus at Microsoft is to recruit and onboard these partners onto our platform so that our customers can leverage their unique capabilities into their missions. And finally, here's a view of the digital thread, specifically geared towards the DIB. Again, notice how the feedback loop is central to the entire lifecycle. The voice of the customer feedback and external validation are constantly being fed back into the design as it advances through its development. And the digital thread runs throughout, closing the loop between the digital and the physical worlds. There is actionable data available at all stages of the lifecycle, and it weaves through product design and development, deployment, operations and sustainment, and indeed business models, allowing the original equipment manufacturer or defence industrial based company to have situational awareness around their own products and capabilities at all phases of the lifecycle. That's huge, and it can afford new business opportunities for those companies. They gain new insights into product performance, usage, trends, anomalies, failures, financials, and returns on investment. And ultimately, That helps them bring new products to market in new ways. Products as a service being just one example of this. And also, from an end customer viewpoint, they are able to influence the development throughout the process and can also have a view of the data generated from the very first phase, meaning that well after the capability has been delivered into sustainment, when they are looking to optimize that integrated logistics support, they have all of the necessary information at their disposal. Believe me, logistics officers everywhere will be rejoicing at the opportunity that this brings. Well, that's been a quick gallop through a high-level introduction to digital engineering. Let's go back to Jono, who's going to take us through some customer use cases.
Hey, thanks, Lloyd. And as he mentioned, I'd like to close now by offering a few customer examples related to digital engineering. But before I do, here's a sample of real-world challenges that we frequently hear from our defence and intelligence customers, especially when we are partnering with them on co-engineering exercises. I'll pause here so you can have a read of the challenges and how we're addressing them. So in terms of addressing these challenges, we frequently partner with Defence Forces and the Defence Industrial Base to address these. We simply cannot do this alone. So by working side by side with a customer and commercial experts who have done this many times over, we can help navigate the common challenges and pitfalls associated with digital transformation and digital engineering adoption. So let's now have a look at those examples, shall we? Firstly, a great example that you may already know well, and that is the NATO software factory. This is a fantastic leading example of modern collaborative environment for software innovation built on a shared cloud infrastructure. The magic here is centered around the fact that NATO members, industry, non-traditional vendors, and academia could all work together in that common environment with easy transition between development, test, and production environments. I think there's also a lot of opportunity for maturation and growth here, though, particularly in terms of consolidating the many different innovation hubs and test beds that exist across NATO environments and nations. And the challenge is then to bring them all together into the core applications and development environment that NATO Software Factory provides. I think there's also opportunity to do some application modernization and technology upgrades to resolve some of those legacy technical debts. The next example comes from our manufacturing team and the Defence Industrial Base. We've actually been working with Rolls-Royce to leverage digital engineering techniques as well as modelling and simulation. They're now using advanced visualization lab that allows them to interact with digital models of products that have not even gone to production yet. They refer to that as zero-cost prototyping and allows you to accelerate what would typically be post-production testing into earlier phases of the design cycle. It's an absolute game changer. It's helping Rolls-Royce to actually drive down their development, maintenance, and sustainment costs through digital engineering methods and modelling and simulation techniques. And finally, another great example where we recently engaged in co-engineering initiatives with a US Army customer, as well as BAE Systems, where our commercial software engineering team spent a few months working side by side with members of the US Army Test and Evaluation Command while building new mission capability using modern development paradigms and methods. Those co-engineering engagements are very popular with our customers because not only do our customers walk away with new capability and IP, but the engineers and the product teams learn new skills and methods in the process. It's fantastic. So moving on, that now concludes our presentation on Microsoft's view of digital engineering for defence and intelligence mission success. Digital engineering is key to digitally transforming the capability lifecycle to meet the agile, adaptive and versatile needs of defence and intelligence organisations. It's been an absolute pleasure to present to you. And if you wish to follow up on any questions, queries or comments, please do not hesitate to contact myself, Lloyd, or our extremely knowledgeable CTO, Kate Maxwell. Thank you.